All right, we are moving on to the most trickiest types. This is as hard as the equations are going to get. Okay, we started with one step, we did two-step, we did multi-step, and if there's any such thing as more than multi-step, this is it. Okay, so today we're going to see variables on both sides of the equation. For example, 7 minus 8x is equal to 4x minus 17. Okay? Remember how I said when you're solving all the other ones, your goal is to get it to look like a two-step equation, right? So like 5x plus 3 equals a number. This is as simple as it gets when you have variables on both sides. On both sides, there's a constant and a coefficient term with the variable, constant coefficient term. Okay? Now, our experience with variables and equations, where do we prefer the variable to be and end up? On the left-hand side. It's just how we were first taught. It's what we're comfortable with. Doesn't always have to be that way, though. And I need you to get comfortable with it both ways. So, but for right now, what we'll do is we'll solve it on the left, and then I'll show you that you could do it on the right as well. Okay, when you approach this problem, I think about it as checkers. When you play checkers, you dump the box out, and you got a big mess. What's the first thing you have to do before you play? Separate them. That's the exact words I wanted you to say. You have to separate the red checkers from the black checkers, right? That's what I have to do here. I have to separate the terms that have variables from the ones that don't have variables, okay? And what we'll do is we'll say, if it's got a variable, I want it over here. If it doesn't and it's a constant, I'll put it over here. You will not always draw this little chart every time you solve. It's just to kind of show you. So, if it has a variable, it can stay. If it doesn't, it has to go. What has to go? The 4x. Or, you know what? And that's the other beauty of this. You can either cancel that out or this out in step 1. In first hour, I canceled that out because it didn't belong here. Let's just get rid of this constant. Minus 7, and I'm going to put it under the like term. Cancels, and you have a negative 8x equals 4x minus 24. Okay? Now what doesn't belong? We're all set over here. This is the constant, but it has a coefficient with a variable, so let's cancel that out next. Oops, I did that in first hour too. Thank you. And then this cancels out. That leaves me with negative 24 and a negative 8 plus a negative 12. Same signs, add and keep. And most of your equations with variables on both sides will turn out looking like one variable over here, one constant over here. Division property of equality says that you can divide and not change expression. All right. Everybody good on how we got 2? All right, now let me just show you something. Let me just take 7 minus 8x equals 4x minus 17. And let's do the same thing, except let's just say you're feeling a little nutty. And let's say that you want to take the constants over here. And you want the variables over here. Shaking it up a little bit. Woo! All right. Now what doesn't belong over here? The negative 8x. So let's get rid of it. And I know what kids' first thought is. They think I'm going to get the opposite answer when I do it like this. Because they're starting to think a little bit, and they see that this 12x is positive, where on the other problem it was negative. And that's as soon as they see that, they think, no, it's not going to be 2. Your answer is going to be negative 2. Well, what's going to happen with this 24 when I cancel this out? The 24 is now positive, right? So if I have a positive 24 divided by a positive 12, doesn't that give me the same answer as a negative 24 divided by a negative 12? Yeah. Yes. So 2 is equal to x, and it works out. There are going to be problems where it'll be to your advantage to sometimes to put them on the left, and I'll show you why. Okay, good so far? All right, let's do example 2. Example 2 says 9x minus 5 equals 1/4 times 16x plus 60. Now, I know what you're thinking. I just showed you the super cool way yesterday to cancel out having to distribute a fraction, right? Yeah, but that fraction yesterday was like 2/3. When it's a numerator of 1, what does taking 1/4 of a number mean? It means divide by 4, right? And the people who wrote this textbook were so nice to give you 2 numbers that are multiples of 4, which means when you go and distribute and you take 1/4 of both of those numbers, you will get a whole number. So in this case, you may want to survey and say, you know what, I'd actually rather just distribute that fraction. Are you good with that? So 9x minus 5 is equal to 1/4 of 16 and 1/4 of 60 and all as well. And as soon as you get it in this format, it's really pretty much just like the one we just did. So I would like you to try to finish that and cancel out. You could cancel out whichever one you want and see what answer you are able to get. Okay? So work on that real quick. We're going to go with the traditional 9x equals 4x plus 20. Now get rid of this. Did anybody get rid of the 4x first? Does your work look different than mine? Yeah. Does it have to look identical to mine? No. There's a lot of different paths to get to the same answer, and as long as you get there, I'm good with that. Okay? So x is 4. Is that what you got? Awesome. Moving on. Ready? Okay. Let's take a look at. We're going to skip example 3 because it's a word problem. We're going to do word problems all together, guys, for the whole section. So let's do example 4. And example 4 has you identifying the number of solutions that a equation has. An equation. And literally last Wednesday, we had a bell work that had you deal with this, right? So if I start you with 9z plus 12 equals 9 times z plus 3 as your first problem, and 7w plus 1 equals 8w plus 1 as your second, and your third will be 3 times 2a plus 2 equals 2 times 3a plus 3. Okay, so get those copied. Now, what are all of our answer choices? We could get one solution. And one solution means x equals 5 and no other number. Like this equation that we just did and we found out that x had to equal 4, that was your one solution. Okay? Could also have no solution. Remember that? And what's the opposite of having nothing work? Having everything work, right? And this is where we talked about, I call it, I'm still old school with that. You'll hear me say all real numbers would work, meaning every number you could possibly think of. Even those square roots of those non-perfect squares, pi would work, okay? Irrational numbers. Then I told you something that this new Common Core we refer to as infinitely many, right? Which I'm not a big fan of, but infinitely many. Many to me just seems like a lot. And today we're going to talk about a third way, because in the back of the book, if there is no, or if it's all real numbers or infinitely many, you're going to see the word identity. And I'll explain why I think that. So let's solve these and let's match. I'm telling you, there's one of each. So when I take 9z plus 12 and distribute this 9z plus 27, technically I can stop right there. Because looking at that, whatever number I pick 6. 9 times 6, 54, add 12 to it. 9 times 6, 54, add 27 to it. It's going to be different every single time, right? So how many solutions can you find that will work in this one? None. Okay? Let me just show you what I mean by that, because I want you to put a little star by B and C, because B and C are only going to happen when your variables cancel out. And let me show you what I mean by that. When I go to put it over here, they cancel here and they cancel here, which leaves me with nothing, which is 0. And 12 is equal to 27. And is that true? No, we know that's not true. So when your variables cancel, I want you to either put true or false. Now, you don't have to write true or false. You need to know what the true or false leads to. False leads to a no solution answer. Good on that? This one looks a little tricky, but now, if I were to subtract 8 from both sides, I would have a negative 1w over here. And then I'd have to divide by negative 1, and that adds a whole nother step. So, are you okay with subtracting the 7 here and putting the w's over there? Which leaves me with 1 equals w plus 1. Now I need to get w by itself, so cancel this out, and I know what you're thinking, and this is why I chose this example. W equals 0. Don't be tempted to say no solution. I found a solution. It's the number 0. Poor 0. Everybody's always thinking that there's something wrong with it, because when you get it as an answer, they're like, doesn't work. Ethan, you need to put those away and pay attention. So, how many solutions do I have? 1. And it's 0. So this is an example of 1 solution. Okay? Last example, when I distribute, I get 6a plus 6 over here, and 6a plus 6 over here. Technically, I don't need to go any further, because those are identical. Hey, guess what? That's probably why they call it the identity. That's why you're going to see that in the back of your book. Just watch what happens, though, if I go ahead and cancel out. Those cancel and those cancel, and I'm left with what? 6 equals 6. So see how last time it was 12 equals 27? Now it's 6 equals 6. 6 equals 6 is not false. It's true. And what do we write for a true statement? Take your pick. I don't care what you write, as long as you know that they are all interchangeable. You will see identity in the back of your book. I like all real numbers. There's like no confusion about it. So all real numbers, however your choice. Okay? Questions on this? All right. So your assignment is going to be page, I didn't write that up there, 157. Numbers 1 through 27, just odds. And I also number 2 because it has you do some writing. Okay, questions? All right, good.